So we're going to create another variable here, another props for the square, which is canSelect. And this will be then square dot piece dot color equals our player turn. Let me get it here in the props. Is equal to player turn. Our square, of course, we need to receive this. There's the isSelected and the canSelect here as well. And it is on click. We're going to say that if and only if canSelect, we're going to perform this function. To not create more and more complexity here on this onClick, I'm going to create another function outside of it, which is the onClick. And here I'm going to check if canSelect, then only so we're going to check here. Select like so. And the onClick is a function, of course, that's going to be called here. You could say that whenever the user clicks on a square that it's not selectable, we're going to unselect the selected square. So then in this case, we're going to say here, select no. Could be something around this, or just simplify then, is selected or cannot select. Be even simpler. But I don't want to do that. I want to only unselect if you click the square that you should click. You come back here, I'm going to refresh. See, we still have some issues. Type error, reading color in the board. Because of course, not all squares have pieces. Yeah, of course, not all squares have pieces. And now that we're saying we're starting with white, if I try to select any of the squares which don't have a white piece, we cannot select, but clicking one of them, here, everything works just like before. With that in place, it's time for us to move our pieces, because what is a chess game if you cannot move your pieces, right? As of now, we can select then our pawns, and I want to select here the D pawn, let's say, and put it on the D4 instead of being D2. So I click on D2, and then I select D4, this pawn should move. But our logic we have right now, canSelect, only checks for the color of the player that is playing right now, to whose turns is it. We need to improve this logic to allow, is it the color of the player that is playing right now, or is it a valid move? And that's very, very important. We need to differentiate from we're just selecting a new piece and we're selecting a square where we want to move our pieces to. I'm going to create here a new const, which will be valid moves. And these valid moves, it will be an array of square models. Or we could just say an array of coordinates, also a possibility. Let's start working on it and see what is best for us. I'm going to create here already a use memo, because we're going to memorize this for sure. And the dependencies we're going to see in a second. Valid moves is any square where the selected piece, there is the selected square, can move to. So selecting the D pawn, it would be D3 and D4. We currently don't have any of this logic implemented, and it's one of the difficult parts, one of the most complex parts of implementing the chess engine or a chess game. So we're going to leave this a bit for later. As of now, I'm just going to say the valid moves is any space there is not a selected square. Let's go and see how this goes, okay? So return our board dot squares dot filter, and here then we have board square. I'm going to say if this board is square dot column is different from selected square dot column, and board square dot row different than select square dot row. Okay, yeah, we're going to return this. So return all of them that have columns and rows different from the one right now. So any other square that is not currently selected. But if there is not a selected square, just return empty array. So we don't even check anything because first you need to select one piece. I'm going to say here, valid moves. Depends on the selected square and also on the board. The both dependencies whenever we want to change this. And on this can select, we're going to verify. And if this square is inside the valid moves square that we have here. So this will be a function, which we're going to say is valid move, sending the square there. Let's create this function const is valid move. I'm going to use here now, use callback, because we're going to memorize the function itself and not the result of it here. So use callback, memorizes a function, use memo, memorizes a result, a variable. I'm going to import it, of course. No, just missing. And here we're going to say receiving a square model and check if square dot row. Better actually, let's just go here. Valid moves dot find or sum. Just verify if there's any that there is here. I'm going to check here board square or valid move square. I check if this valid move square dot column equals square dot column and valid move square dot row equals square dot row. Simple like so. So the idea here is to return. Now, this will be return a boolean, not this here. So return a boolean because we want to return if this square is a selectable one. I'm going to add the dependencies here for our use callback, which of course it will be on our valid moves. Every time the valid moves change, this function needs to be recreated, and then the result, of course, the same. This valid move is already being set here. Let's go back to our application and select, and nothing happens. Why is that? So coming back to the code, checking out the logic, we see here the can select. This is an or, because or is the same color of the player's turn, or is a valid move. And also here in the valid moves, this is an or as well, because the selected square needs to be the same column and the same row. So if any of those is different, it's not the selected square, it's not the same square. Now let's check again. I'm going to refresh. Try to select anything in the middle of the board. Doesn't work. Select white piece. It works just fine. And now if I select anything in the middle of the board, it works because I have a white piece selected. I'm going to unselect. Okay, we cannot select again, but now if a white piece is selected, I can start selecting squares in the middle of the board, which is of course not ideal. We want to allow only to select the possible destinations, but just to check it out that we can make this is valid move now a correct function, and with that the selects the squares will be correct. And to visualize that, I'm going to create a small style in the square itself whenever this is a valid move. I have here the coordinate column, coordinate row, and the square piece. Let's create a span, which I'm going to use maybe the same background that we already used here, this PG Gray 400. Going to say with 2, height 2, let's see if this is too few. Yeah, it's quite few. Let's add this to a 4. And now also added a rounded full, if I'm not mistaken. Yes. So this is the squares. I want to show this in the squares that can be selected. As of now, I'm editing all of them, of course. So we need to create another property, another props, which is not just the can select, because can select is the logic which can triggers the click and allows the user to, of course, then select the square itself. We want here to say if this is a valid move. So is valid move. Or even better, show valid move. I'm going to call this Boolean, show as valid move. Let's bring this here. I'm going to add this one here and this one on top, keep the same. And now if show this is a valid move, we're going to print this out. In our board, I'm going to repeat this. So show as valid move. And I'm going to repeat this one. Why am I putting this one in the can select and this one as a show valid move instead of just using the can select being this one and then show as valid move this one? Because I want to add in the future the possibility of disabling completely this valid move to show as valid move. So to never show what are the valid moves. This is good if you are training chess to not always depend on seeing which moves you can trigger. It's very good for beginners, but not something that advanced players will use. So for that, I want in the future to be able to disable this. And for this reason, I'm completely separating it from the can select function. We're still going to improve the performance here, of course, to not keep this being repeated and being called the same function twice. But for now, it works. It's what we want to look for. Going to refresh. If I select this square, all of the other ones become with that small circle. Going to select this one, these ones, perfect. Everything else is selectable because it's what we have in valid moves as of now. Just before we really calculate the correct moves, I want to go back to our square and verify, make slightly different, the style if there's already a piece inside this space where we want to select. For example, we want to capture a piece of the opponent. We're going to have here then show as valid move. It will be this one, sure. But then class name, I'm going to say it's a string literal. And inside of it, we're going to verify for if there is a piece, just a piece, not necessarily our piece, because this is the responsibility of the board to say that they selected. My pieces are not capturable. Okay, so now I'm going to just select here if square, oops, here square dot piece. If there's any piece, we're going to apply this. Otherwise, we're going to apply what we already had before. Now we have here. We see that these ones disappear, perfect. And now let's add, here I'm going to say that it will be bigger, so maybe with 8 and height 8. Instead of background, I'm going to say a border 2, border color, if I'm not mistaken. Don't remember how to put colors in the border. So here, border color, border, yeah, let's go. Border gray, border gray 400. I'm back to our application. Okay, seems kind of fine. I just forgot our rounded full. This can be for all of them, so I'm going to bring it off of it. And now there I have it. Nice. It's a bit bigger. I'm going to transform this border maybe in border 4. Too much. Let's keep it border 3. Border 2 doesn't exist, so I'm sticking with border 2. This, of course, needs to be not putting the icons of the pieces to the side. They need to be together in it. So I'm going to add this an absolute. And here we have both of them living harmoniously together. But border, this, it's not enough. Let's add this even bigger to be outside. Yes, like so. So we can capture this piece which is inside this square. I think it looks a bit better than, of course, just have the dot on top of it. With that finally done, we can go to our board and start working on the valid moves themselves. As of now, the valid moves are a square model. What I mentioned earlier, I was not sure if this was really going to stick, and I don't think so, because I don't want to have this square model with all the information and the reference to this square model in the valid moves. The coordinates suffices. So we're going to keep just the coordinates here, and we're going to use it, that will be it, instead of having this whole reference. Our square model then, of course, cannot have a row and column, we can have just a coordinate, and these coordinates will be a coordinate model.ts, just an interface. Coordinate model should have a row number and a column number. Simple as that. In our square model, we replace this by coordinate model, like so. Now here we're going to say coordinates, type of coordinate model. When we start a square, we can still start with row and column, but now we need to create these coordinates equals row and column. Simple like that. Can even put this on one line, I think. Let's see if my printer will organize. Yes, that's good. Get column coordinates. It says this dot column, this dot coordinates dot column, and here this dot coordinates dot row. The same. Adjust everything. Coordinates dot row, coordinates dot column. Piece is still the same. Keep it as is. We're going to work with it later on. And now let's go back to our app TS. Here we don't use squares at all. In the board we do, and see all of these errors already showing up because dot row and dot column now are dot coordinate dot row or dot coordinate dot column. Let's make a replace of all of them. Here dot coordinate column coordinates row, sorry, not easy. Here and now the column to the column. Okay, that looks a bit better. And in our square component per se, we receive a square. Do we use a square here in anywhere? No, we don't use, just get the column coordinate, which is already coming from the square model, so no need to change anything there. Comment here, to refresh, and it should have still working exactly as before. That's quite nice. Just with this small refactor that now allows us to use in the valid moves, instead of an array of square models, we're going to say an array of coordinate model. And filtering here, not just a filter, we're going to use a map. And then or just filter and then map can be as well. Board square, going to return board square dot coordinates. It's missing something here. Coordinates, like so. So we filter and then we map all of these squares into coordinate models. And in the isValid move, as now the valid move is a coordinate per se, we're just going to say here coordinates instead of valid move square, to rename it a bit, to check against the column and the row directly instead of checking, of course, against a square model because it's not a square model anymore. With all of that done, we have our groundwork, our base, to change this into specific coordinates. Let's create then a service, which I'm going to call the move service. .ts, let's say, export const get valid moves. Receives a square of type square model, as you can imagine, and return an array of coordinates. Here, coordinate models. First thing we need to check if there is a piece in this square. So if there is not a piece, return empty array. Else then we're going to return something we don't know yet what. Technically it would be this, but we know that this is not what we're looking for, because this is just returning everything, right? Like all the possible squares and not the squares that the piece can really move into. And now here on the board, let's go then get valid moves, replace for the function we just created into the move service, sending the selected square there. And now I'm just going to return directly because the move service already makes this verification about selected square for us. We don't need the board as a dependency anymore. And this is how it would be our board per se. We just send this directly. In the valid moves, this could also be null. So I'm going to make just a check here. If there is square, there is not square, or there is not a square piece, return already. Empty array, perfect. Otherwise, we're going to return the movements of this piece. Considering then if this piece is of type, that's what I have here, type piece type dot pawn, for example, this can only move forward. The pawn can only move forward. And what I want to do here as of now is that instead of thinking about the pawn hitting other pieces, or even like, I don't know, select the bishop. The bishop cannot move because it's blocked by the 2 pawns. As of now, I don't care about that. As long as the square exists in the diagonal of the bishop, I'm going to allow it. The knight the same, the rook the same for all the pieces. I'm not taking consideration the state of the board. I'm just going to consider the movement allowed for this piece given its normal movement. And for the pawn, it's to go forward. And going forward is increasing the number of the row. It's basically what we need to do. So what I'm going to get here is const row and column of the current position. So now we're going to have here square dot coordinates. Thus this is structuring the coordinates, not repeat all the time. And we're also going to create const final moves, valid moves, or just valid moves, empty array, but this array is of type coordinate model, returning in the end current valid moves. And if the type is pawn, valid moves dot push a new coordinate, which will be row plus 1, and column the same column that we already had before. And also row plus 2, because in the first movement the pawn can move twice. So whenever it's starting, the pawn can move 2 paces forward. If I select here now our pawn, nothing shows. Let's see why. Let's try to understand in our code. And the problem should be in here, the move service. Yeah, here. So if not square or not square piece. The logic was wrong here in the line 6. Now coming back, we see that the selected pawn can move 2 rows. So to the row 3 and to the row 4. But this movement here, to move 2 rows at once, it's only allowed for the pawn if it's the first movement of this pawn. So we need to verify here if the row is equal to 1. So if you are in the row 1, there is the first row. Here it's the row 2, but remember that we start from 0. So this is the row 1 for us, index. If the row 1, then the pawn can move twice. And that's it. Simple as that. However, it's not as simple. What if we're playing with black? Black moves down the board. So instead of increasing the row, we need to decrease for black. So we need to make a verification here in this if. Let's say square dot piece dot color equals to piece color, player color dot white. These rules only apply for white. Else, then of course it's black. We're going to do the opposite, row -1 and row -2. And now here it's if row equals to 6, so the previous last row. Let's just change the logic that we have here on our FTS, that we say player turn start with white, to say to start with black, and see how our board then works with that. Now if I try to select white, I cannot because it's technically black's turn. If I select black, here we have the 2 possible movements for this pawn for black. And this is, in a very simple way, what we need to do for all of possible pieces, for the pawns, for the bishops, for the rooks, the queen, so on. We need to verify the piece type, the piece color, and check what are the possible moves for this combination. But this is something we're going to do together in the next video, because this one's already quite big, so I'll see you there.